Sometimes the innate system, even with the help of billions and billions of microbes, is still not enough to ward off attack. When phagocytes, macrophages, and neutrophils, together with inflammation, prove insufficient, then it's time to call in the special forces, the lymphocytes, the T and B cells that launch adaptive immunity, the amazingly targeted and specific response that not only delivers a powerful punch, but also learns from experience. T and B cells are armed with highly specialized cell surface receptors that differ from PRRs, the pattern recognition receptors. Remember, PAMPs are general structural patterns that via PRR binding distinguish between us, that is to say, self, and non-self, foreign pathogens, for example. LPS is common to many bacteria, as is double-stranded RNA, a good marker for viral infection. But recognizing binding these markers does not reveal the kind of bacterium or which particular RNA virus has infected us. In contrast, lymphocyte receptors are amazingly specific and are designed to recognize exactly the type of bacteria, virus, or other pathogen we must fight. The adaptive immune response relies on three main functions of lymphocytes. Lymphocytes recognize and bind specific markers of the pathogen and are able to discriminate these from self-markers. The molecules lymphocytes recognize and bind are called antigens. Most antigens are proteins. However, sugars, lipids, and even DNA can also be antigenic, that is to say, recognized by our immune system. Hence, lymphocytes must discriminate between foreign antigens and self-antigens, and they do this using their special receptors. Lymphocytes respond to the presence of pathogens and take actions to knock out and clear infections. As we will learn, when B cells bind foreign antigens, they produce unique proteins called antibodies. Antibodies are like highly sophisticated guided missiles that target the pathogen with precision and often neutralize it completely. Binding foreign antigens by T cells activates them to become aggressive killer cells that can identify and knock out infected cells where viruses and intracellular pathogens may be hiding. Finally, lymphocytes archive immunological memory. In order for T and B cells to respond precisely against specific threats, they undergo training, fine-tuning their receptors and their ability to respond. Once the T cells and the B cells have gained experience and got it right, they deposit their best trained and most experienced cells in a memory bank. Archived memory cells can live for decades and are always ready to ignite an aggressive and bold response the moment a pathogen of the past attempts to infect us again. Launching a precision, massive attack on second-round infections is the essence of immunity. Let's compare the course of action of the innate immune response with the adaptive immunity. Assume a specific bacterium, let's call it antigen A, has breached our skin. An induced innate immune response is launched. Macrophages immediately begin to stuff themselves, yet the bacteria are still replicating, and backup forces of neutrophils are called to the scene. Ultimately, during the course of a week or so, things come under control and all is good. Now, let's say that you encounter the very same antigen A sometime later. As you can see, this secondary innate response to the same pathogen simply repeats itself. It's no better nor worse than the primary encounter. Now let's say that the battle didn't go on so well, and the macrophages and neutrophils needed to call in the special forces, B and T cells. This is done by special cells called dendritic cells, the intelligence arm of the immune system. Dendritic cells capture invading pathogens and transport them from the battlefield to headquarters, special organs called lymph nodes where T and B cells hang out. T and B cells study the pathogens and develop highly sophisticated and powerful responses custom-tailored to knock out the specific pathogen. Learning how to deliver an effective blow may take a week or so. Hence, there is a lag before the maximal effect of adaptive response begins to kick in. Ultimately, the pathogen is cleared. However, should the same pathogen infect us a second time, now the adaptive response is launched from the get-go and with exceptional force. Here, the secondary response is immediate, far more intense, and dramatically more effective. This is due to the fact that once T and B cells have learned the details of pathogen A, they deposit memory T and B cells stored in the archives of the adaptive immune system, ready to launch a death blow to the pathogen before it can cause damage or disease. In the coming lesson, we will see how B cells produce antibodies that can target and neutralize viruses. We will also learn how T cells identify those cells of our body that have been infected and need to be destroyed. Finally, we will discuss situations where the immune system overreacts and what happens when immunity is compromised and deficient.